very crucial concepts. Starting off in the previous class, we studied a bit about what's binary, the basics of binary, especially how do we convert binary into numbers. This was basically what we studied in the last class. Today we are going to be discussing the denary concept. Then let's just wait. Give me a minute. Let me enlarge this. How do we do that? Yeah. So where do you? Yeah, oh man, that's so difficult. But yeah, 50. Okay, so we're going to be studying the denary concept followed by what's one's complement and two's complement. A bit of these concepts are already taught in O levels, especially the denary concept, the one complements concept, and the addition of binary concept and the hexadecimal concept. But we are again going to be moving from the scratch so that everyone, even those who didn't have O level CS, they could also get the entire concept. And that's the purpose of creating this course, so that everyone get to know this idea of how A level CS, especially ASCS, is. So let's start off. In the last class we discussed how we convert binary numbers into denary, sorry, into numbers. Now the first thing which we need to understand today is the denary concept. So denary concept starts off with the terms denary. Now we all know these numbers, right? 1, 2, 3, 4, 5, 6. And yeah, repeating, if the voice wasn't clear or there was any other issue, please do turn on your mic and tell me, because I cannot see your messages. So yeah, 1, 2, 3, 4, 5, 6, all these numbers from 0 to 9, we call these numbers, right? Numbers in our day-to-day life. But we have to but in the world of computer science, basically we call this denary, denary, denary number system. So numbers in our basic English, and in terms of computer science, we call it denary. And so denary constitutes of number from 0 to 9. I hope this is clear. Now, in yesterday's class, we studied how we convert binary into denary. Now let's talk in computer terminology. How do you convert 11010011 into numbers? By assigning the weights 1 to 4, 8, 16, 32, 64 up to 128. And let's say we get a number up here 256. Today, the first thing which we are going to be learning is how do we do it the opposite way? Like how do we convert 256, perhaps not 256, let's change it to 124. How do we convert 124 into binary? Now, there are two main ways of doing this. Okay, the first method is of putting the numbers according to their weightages. Like let's say we had 1, 2, 4, 8, 16, 32, 64, 128. These were the weightages for each of the binary digit, right? And now if we put 1 in all those places, when added up it gets 124, we get the binary value. Like let's do it. 128, no, that is greater than 64. We're gonna put 0 up here. 64, yeah. Then plus 32, yes. What do we get? We get 64 plus 32, that is 96. 96 plus 16, definitely. We get as 96 plus 602 and 102, 112. Yeah, we get 112 up here. One other thing, calculators are not allowed in your AS or A2 CS examinations, because you guys need to have these skills on how to do these basic math calculation. And so 112 plus 8, we get 120, right? And now 120 plus what number equates up to 124? It's a 4, right? So yeah, adding up all these 5 digit values, we get 124. So for the remaining, we're gonna put 00. So we get the value as 01111100, and this binary basically represents 124. Now this concept has already been taught in your O levels, but again, for the purpose of the students who didn't took O-level CS, it's for them that you guys should be able to convert these binary values into 124, and again numbers or denary back into binary. Now this was the first method. Now the second method for doing this is, let's start off up here. Yeah, the second method of converting binary, not binary, perhaps denary into binary. Doing this is also quite similar. This method involves division, okay, constant division, or what do we, or the LCM method, perhaps LCM method, because we use this type of division mostly in the LCMs, the maths concept. So let's say we have, let's not up here, let's do it up here. Yeah, we had 224, right? 124. 124 divided by 2 is 62, right? We have 0 up here. Then after that, we gonna do it again with 2, we're gonna get 31, 0. 2 divided by, we're gonna get 15, right? And we have 1. 2 again divided by 7, we're gonna have 1. 2 again 3, we're gonna have 1. 2 again 2, we're gonna have 1. 2 again 1, we're gonna have 0. So yeah, we had the binary 1 0 1 1 1, 4 ones, 1 0 1 and 0 0, 4 up here, 4 up here. Let's check it out. Was it the same as the previous one? Let's wait a minute, let me check it. We had 0 1 1 1 1 0 0. Man, why am I getting it wrong? Yeah, wait, let's check it again. 1 second. Hmm, wait a second, I am messing it up somewhere. We should be ideally having 5 ones. Wait, why am I getting it? This, and we should be okay. Towards the end, you should have 2 3 1. Okay, 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 okay. I got it. I got it. Okay. We're gonna get 1 up here. My bad. 2 ones are 2, and we have 1 remainder, and then 2 zeros are 0. Now we should have again 1 remainder up here, like this. And now you get the correct code. My bad, guys. It should be 0 1 1 1 1 1 0 0. Now the mistake which I was doing previously was that when dividing 3 with 2, we have the remainder as 1, not 2. I was basically writing this 2, and because of that I was getting an error up here. And now 1, how do you divide that? 2 divided by basically 0, you get 0 up here, and then we have 1 as the remainder. And so your binary code is 0 1 1 1 1 0 0, which is exactly the same which we got previously, 124. Now, sorry for making this all a bit confusing, but yes, this method is confusing. And just like the way I made an error up here, you guys could also make similar errors. And for this reason, I would always suggest using the first method, which was putting the values using the first method. Because the first method is quite simple, to be honest. It's not that difficult. So yeah, we have to write the remainder in this section, in this part. Basically, you don't, basically, the main thing up here is that if you got a remainder, whether it's 3, it's 2, 1, whatever, if we have a remainder, we have to put 1 up here in this part. And if we don't have a remainder, we're going to put 0 up here. So the main concept up here is just that if you have a remainder, you need to put 1 in this part. If you don't have a remainder, you just have to put 0. You don't have to put the exact numbers, because you see we have associated or like converted this column to into the binary column, right? And binary is always in either 1 or 0. And in the last class we said 1 is used to represent the on function, whereas 0 is used to represent the off function. Likewise in here, if you have a remainder, we're gonna, place 1, and if we don't have a remainder, we're gonna put a 0. I hope this clarifies. If not, do let me know. I would re-explain this concept. But yes, this was a bit confusing, because the main reason behind this is that you have to consecutively divide one number with 2, find the remainder, and then place them in a column. And yes, one other thing, you always have to go from the downward side towards the up, right? We did it as 0 1 1 1 1 1 0 0, not as 0 0 1 1. This is also a common mistake. Let's write it up somewhere. This is a common mistake. Common mistake. And that common mistake is that students, read it, students go from top to bottom. Whereas this is 100% wrong. You need to go from bottom to top. And the bottom one is the element or the digit which is at the most left side. Like if we have this binary number, this most left one is your bottom digit, and this most right one is your top digit. All right, I hope this clarifies. So yeah, now once done with this, you guys have studied the two main concepts, which were about binary to denary, and then denary to binary. Now in the books, you're gonna see this term that denary is a base 10 number system. Now, as told in the previous class, base 10, in the previous class, basically for the binary we studied, it was base 2. Now, here we have base 10. What do we mean by base 10? By base 10, we basically mean to say that we have 10 possible options. And what are those 10 possible options which we could place in one single spot, one digit? Those are 0 till 9. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we count all these, we get 10. And just because we get 10 digits up here, we call it a base 10 number system. Now, the main purpose of these classes was to make the computer science a bit easier. Now, the problem was usually in our own school, when the teachers try to explain this concept, they're not teaching us why do we call this a base 10 number system. They're like, just memorize it, yeah, it's base 2, base 10, base 16, whatever. But you need to get the understanding behind why do we call it base 10. The main reason behind this is that because it has 10 possible options. If, let's say, in mathematics we had 11 possible options, then it would have been base 11 and not base 10. I hope this clarifies. And now, once done with this, so now we are going to be studying this topic. Wait, I got a message. Okay, the student is joining up. Okay, no worries. We are going to be studying addition of binary elements, which is something very, very important. This used to be tested in your O levels, but this wasn't tested in that much great depth back then. But now you're going to be studying addition as well as subtraction of the binary values. Let's do a small example. What's 10 plus 2? We get 12, right? Similarly, if I tell computer to add 10 and 2, it won't understand what 10 means until or unless we clarify it to them using some sort of programming language, right? Or we have some sort of programming code which specifies what 10 means in binary and then what 2 means in binary. Now, the main in this course currently we are going to be studying. Is my voice clear, guys? Is the voice clear? Hello. Yeah. Okay. 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 Yeah, so I was saying that computer only gets to know what binary means, right? So in binary, we need to first convert these digits 10 into binary, and then we could add those binary numbers later on. So what's 10 in binary? We gonna write the values up here: 1, 2, 4, 8, 16, 32, 64, 128. Let's take a bit of a bigger number, 90. So 90 would be 0, 0, but not 0, my bad. It's going to be 1 and then not 32, because 64 plus 32 is going to be 96, which is bigger than 90. So we're going to put 0 up here, 16 up here, which comes up to be 80, 88, and then 90 and 0. This represents the value 90 in binary. Now, let's say the second number is 12. We're going to write 12 up here. We have 8 and then we have 4. So we get these two binary values. Now, yeah, is there any question? No, is there any question? All right, not. Okay, so when adding up these two, wait, we do have, okay, okay. So yeah, I was saying that when adding these two binary values, we have some rules to follow. In maths, what do? We have 2 plus 3, we directly say it's 5, right? Similarly, up here, you need to memorize some very, very important rules. And I would say that if you guys have a register and you haven't studied this previously in O levels, do write these rules somewhere. When adding 0 plus 0, the final answer is also going to be 0. In this case, 0 plus 0 is going to be a 0. The second one is if you have 0 plus 1, you're going to be writing 0, but you have a carry to the next element, to the next digit, to next digit. Carry to the next digit. Like up here, 1 plus 0, we won't be writing 1 up here. No, we are going to be mentioning 0 in this section, but we are going to be taking the carry up to this one. So now we are going to be considering 1, 0, and 1. The third rule is if you have 1 plus 1, okay, guys, we have the last 10 minutes and then we're going to be starting off again with the recording. So 1 plus 1 is going to be 1. Now, these are the three main rules which you guys study in O levels usually. Now, coming up again, if we have, and the same rule applies in A levels too, but in A levels, sometimes you have the addition of three binary values. How do you do that? Let's say we have 1 plus 1 plus 1. This is one exception. Apart from that, all the other is quite similar. Like if we have 0 plus 0 plus 1, we are going to be considering it just like the 0 plus 1 because we're going to ignore this 0 and we have the same 0 plus 1 left off. And so 1 plus 1 plus 1 equates to 1 and again carry with a 1 to the next digit. Now, these are the main four rules you all need to memorize. This is something you guys have to learn by heart. Now, let's add these two numbers. Let's get this. 0 plus 0 is 0. As per rule number 1, let's number it. 1, 2, 3, and 4. 1 plus 0 is 0 with 1 carry. Which rule is this? This is rule number 2. Then we have 1 plus 0 plus 1. This equates to the same thing as 0 plus 1 plus 1, which is rule number 3. What do we get? We get a 1 up here. Now again, we don't have anything. 1 plus 1, 0 with 1. Okay. And wait, yeah. And again, 1 plus 1 plus 0, same thing up here. 1 plus 1 is going to be 1. 0 plus 0, as per rule number 1, is going to be 0. 1 plus 0. Wait. Guys, could anyone correct me if this is how we do it? Or did I just mess it up? Man, why am I forgetting the concepts? But yeah, 1 plus 1 plus 1 is, wait, just give me a second. Let me check the book. The book had the rules up here. It was 1 plus 1 was a 0 with a carry of 1. Oh, yes, exactly. I messed it up. Let's erase everything. Let's start from this start. I believe I ain't feeling well today, but yeah, I messed it up. Wait. The rule was that if we have 0 plus 1, we are going to be getting 1.
Walaikum assalam.
Walaikum assalam ji. Hello. Yeah, I was saying that if we have 0, yeah, I would share the book in the group once again. You guys have to use the Harder Education book. Harder Education book. That's the best book out there because it has all the content, topics, stuff mentioned in detail. And so, yeah, starting off again, yes. Now you need to know these rules. If we have 0 plus 0, we are going to be getting 0 in the end. If we have 0 plus 1, we are going to be getting 1. If we have 1 plus 1, we are going to be getting a 0 with a carry. And if we have 1 plus 1 plus 1, we are going to be getting a 1 as well as a carry with a carry. So yeah, these were the four rules. I also got a bit confused. I was like, what is happening? But yeah, let's add up two simple binary digits such as 10110011 and 01110101. Let's add these two numbers. Now 1 plus 1 as per rule number 3 is going to be a 0 with 1. Then again, 1 plus 1 plus 0 is again going to be rule number 3, 0 with a carry. Again, 1 plus 1 plus 0 is going to be 0 with 1. Now up here we have 1 plus 0 plus 0. We are going to follow rule number 2, which would be 1. 1 plus 1 would be 0 with carry number 1. Now this is rule number 4. 1 plus 1 plus 1. We are going to be getting 1 and a carry up. 1 up here. Again, 1 plus 1 is going to be 0 with 1, and 1 plus 1 is going to be 0 with a carry up here, which you guys have to write like this. Now, a question would be up there that we have 9 digits. We don't have 8, we have 9 digits. Now, this is known as an overflow error. Overflow error. And why does it occur? It occurs basically, we discussed it in the previous class, that we store digits in a register. A register could be of 8 bits, 9 bits, 10 bits, 8 bits, 12 bits, 16 bits, and so on, 32, 64, up to 128, 1024, and so on. But yeah, we have 8 columns in this. Now, let's say these 8 columns could represent a maximum value of 256. Not let's say, this is something which you have to memorize. Yeah, these 8 bits represent a maximum of 256. Like the positions which we identified previously, those were 1, 2, 4, 8, 16, 32, 64, and 128. When we add up all these numbers, we get 255. This means that in this register, the maximum value which we can store is of 255. We cannot even get to 256, which limits the entire register capacity at 256. And so the maximum value which we could store, that is 255. After that, let's say if we have a digit up here, that is going to be 256, then 512, 1024, 2048, and so on. And so this ninth bit which we receive, this is having a value of basically 256, which we cannot store in this 255 register. I hope this clarifies. Our register of 8 bits could only store these 8 bits. If we had a register which had 12 bits, then we could have stored the value of the 9 bit, 10 bit, 11 till 12. But we cannot do it right now because we don't have the space. Okay. If you guys could mute your mics, that would be highly appreciated. Okay. So yeah. So I was saying that the 9 bit is going to go is basically we cannot store this 9 bit up in this 8 bit register, guys. So in a register of 32, you can only store 31 bits. No, you can store 32 bits. Basically, this was the position value. You add up these numbers 1, 2, 4, 8, 16, 32, 64, 128, you get 255 as the answer for the values. So yeah, if you have 2 raised to power 32, which would be the total number of values you could store in a 200 in a 32-bit register, you would be maximum able to store 2 raised to power 32 minus 1. Like in this case, we have 8 bits, right? So 2 raised to power 8 is basically 256, but the maximum we could store is 2 raised to power 8 minus 1, which is 255. I hope you get this. Well, this is something only I wanted to tell you all for your concept. You guys don't need to memorize this a lot, but if let's say in exam you get a question, let's erase this part, that you have an 8-bit register, 8-bit register. How much, basically this question mostly comes in the fill in, not in the fill in the blank, in the match the column section. They say 8-bit register, and then you have values such as 312, 255, and so you need to match it to 255 up here. Or even sometimes when you don't have a 255 but you do have a 256, also go with 256. We are going to be discussing this later on in the 2's complement concept. When do we use 255 and when do we use 256? This is something which we are going to be discussing later on. But yeah, this was basically how you add these two numbers. You see, we get this new binary. When we again convert this new binary into again denary form, you're going to get the same answer if we had added or subtracted these two binary values. So yes, this is the addition part. Now afterwards we are going to be studying what we are going to be now studying the subtraction part. How do you subtract two binary values? Now, this has not been taught in your O levels, and so I would appreciate if even the students who had O level CS, they also hear it quite properly, because we have studied 3 plus 5, which comes up to 8. But how do we convert 8, the same thing into subtraction form, or perhaps 8 minus 5 into 3? Now, again, there are two things about this. We have less than 1 minute for the call, and then I'm going to be sharing up the link once again in the group. You guys should join up immediately so we don't waste a lot of time. And so, yeah, there are again two methods, but I personally would only be teaching the method which I find easy because that is quite straightforward and you don't have to memorize the rules, because in the second method you have a lot of rules which makes it quite confusing, to be honest. And I would say that you only need to memorize these four rules. So I'm going to be sharing the recording. If you guys want to take a screenshot, just take the screenshot and later on write it on a register or something, because this is really, really important. And so I'm just ending the meeting right now. I'm sending the link immediately again, and you all should just join up. Record. All right, starting again. Now we're going to be discussing subtraction. Subtraction in binaries. This is a new concept again. This was not in O levels and this has been introduced in your AS syllabus. Now, how do we subtract two binary values? Now, the two methods basically involves, one is using logic and the second one basically has some rules. I personally don't prefer this rules one because you get the same answer from both the methods 100%. I have applied it everywhere, and I would personally suggest you guys just go with the logic one. And so we would be erasing this part. And what do I mean by the logic part? Let's say you have a number 23 and then you add a negative number into it. What do we get from this parenthesis? We have 23 minus 32, right? We get it directly that if we add 23 into a negative 32 number, we should have the answer which subtracts the two value. Now for this method, we are going to be firstly studying ones complement, or the method of how to convert a positive value binary value into a negative binary value. We have studied how do we get 12 in binary, right, using the weightages, but how do we get minus 12? That is something which is really, really important, which many of the students don't know. And so for that, just an easy method. Let's say, yeah, let's add some space up here. Yeah, so let's write 12 in binary form: 1248, 16, 32, 64, and 128. According to the weightage, we get 0, 0, 0, 0, 8, 4, and 0, 0. So this is your binary form for the denary value 12. This is clear, right? Yes, 12. Now, how do we convert this positive 12 into negative 12? Converting a positive number into negative number is really, really easy. Do you know? You just have to flip the numbers. How do we flip the values? Well, a 0 becomes a 1, 1, and a 1 becomes a 0. 1, 1, 1, 1. This number, new number, represents negative 12. Wait a minute. Just a second. I have, wait a minute. Yeah. Now, this, what do we call it? This concept basically is known as one's complement. You are going to be looking at this in the book too. Once we are done with the chapter, I would be suggesting you all guys go to the through the book, because after you have studied everything, everything is really going to be very, very easy. I'm also going to be sharing some notes, so it's also easy that way. But yeah, this conversion, the flipping part is known as one's complement. And now after we flip it, when we add one in it, the binary value one in it, we get the answer in two's complement. Two's complement. These are two terminologies. Basically, this is to just make it a bit confusing, I would say. But yeah, once you add one into it, let's say what do we have now? So we have 1 plus 1 is 0 with 1, a carry up here. 1 plus 1 is again 0 with 1. 1 plus 1, this is perhaps with, yeah, 1 plus 0 is then a 1. So we have the binary number up here. Now, this binary number which we get in the end after adding 1 repeating into the flipped value, this binary number represents minus 12. Now, let's just go through this again. Let me write the entire steps of how do we do all this. Firstly, you need to calculate. Let's remove everything. Yeah. Step number one, write the number, the denary value in binary form. The positive one. Again, this is the positive one, not the negative one. Step number two is basically to flip the values. Flip the values. 0 becomes a 1 and a 1 becomes a 0. Okay. And then the third one is add 1 into the flipped binary equation, into the flipped binary, not equation, binary number perhaps. Yes, binary number. Now the answer which you get from this, that represents the negative form of the initial binary positive number which you converted into the ones complement form by flipping it. So this second step, step number two, where we flip the values, this is known as ones complement, ones complement. And once you add 1 into the ones complement, you get a twos complement. Now, many of the students basically don't get this concept. They are like, what's the difference between ones complement and twos complement? And this is really, really easy because you just need to understand that in ones complement, you just like, you could say that in converting the numbers from positive to negative side, you have first the ones complement, and then the second step basically is twos complement. In ones complement, you just flip the values, and then when you add 1 into it, you get the twos complement. And so when we were discussing the weightages part, you guys should remember that we had this concept like 1, 2, 4, 8, 16, 32, 64, and 128. But what happens when we convert it into twos complement? When after we convert after the first complement binary value, when we add 1 into it, what happens is that this 128, the most left bit in the 8-bit register, this converts into negative. This most leftward bit, the most leftward bit, this is known as MSB. By MSB we mean most significant bit. Most significant bit. Sometimes they give you a binary value like this, and they say, which one is the most significant bit? This one or this one? Well, it's this one, the most leftwards, or perhaps the one which has the greatest value. Now, this most left bit, this basically becomes negative. Now, if we again convert it in from negative now in this form, if we want to get, let's say, positive negative 120, how are we going to get that? We're going to first put 1 up here. Now, minus 128 plus what number gives us 120? Just tell me. It has to be 120 plus 128. Basic math, let's say this is x. And so x is going to be 248. No, how is it? Oh, my bad, my bad. Perhaps it has to be something like, oh, my bad again. This has to be minus 120, because if we shade this one, we have to get the final answer as minus 120. And so minus 120 plus 28 gives us the answer as x equals to 8, right? Now we need to shade or put 1 under those blocks. When added, we get 8, which we have directly 8 up here like this. So if we fill the other part of the binary value with 0, we have this binary value for 120, but negative. Now I'm going to be now discussing a very, very important thing. This is basically a question which is mostly tested in your examinations. They tell you firstly that use twos complement. Okay, this is in the question. They say use twos complement. So mostly when students hear the term twos complement, they get confused. They think if we have to give the answer in negative form, well, that's not must. You could also give your answer in positive form. How? You see, we had this part, right? Let's erase this. Let's see. We have this part. In twos complement, what's the difference? We only get the 8-bit as negative, but the rest is the same. Let's say if I had to represent positive 10 in twos complement, how do we have to do that? We have to just put a 0 up here. 0.008200. Get it? Now we are representing positive 10 in here. But if we want to represent, let's say, a negative 10, how are we going to do that? We need to first turn this bit on, 1. And then we need to shade all those numbers so that in the end we get the answer as a negative 10, which would be perhaps 128 plus x is equal to negative 10. And so I would suggest you use this mathematical form because it makes it quite easy, and this isn't that sort of advanced algebra or something which is quite difficult. Perhaps it's something very, very easy. You get it as a minus 10 plus 128. You need to shade 118. So now how do we do 118? 64, 32, 96, 96, 4. What do we get? 96, 100, 116, 218. Now you all would be thinking, how am I doing it all this so fast? Well, basically it's just because of the practice, nothing else. And so yeah, whose complement done. This is basically a question which you guys could be tested upon. They first say to convert the denary value 20, positive 20, into positive 20 into a binary form, but in two's complement. And so many of the students basically they think like we need to get the answer as negative 20, but no, you need to give positive 20 in the perspective of two's complement. And then the second part is going to be convert the same 20 into negative 20. Okay. And also there is one other part of question, other similar question too, which you usually get tested on. And that is in the first part, they tell you, what's the binary value of 20? What's the binary value of 20? Okay, that's the main question. The first part of the question. You give the answer as, let's say, 11001100. This isn't 20, but let's say you give this equation. And then in the second part, it says, find the ones complement of the same 20, complement of 20. How are you going to do this? You are just going to flip the value 00110011, and this is your ones complement answer. This is something very, very important because many people don't basically understand this concept. And so to be honest, this part is something which even sometimes the teacher aren't able to clarify. Like when I was doing it back in my O levels, I personally didn't know what's the difference between one's complement and two's complement. And then I learned this shortcut that the first step where you flip the values, that part is known as the one's complement, whereas the second one, when you add one into the flipped value, that is known as two's complement. Let's add something from the book in here. Yeah, let's take this example. Just give me a minute. Okay, we have this example from the book. Let's copy it and put it up here. Where did it go? Yes, up here. Bring it up here a bit. Yeah. So you see, we have minus 128, 64, 32, 64, 428. Now we need to first, what we did up here, we just converted, basically, what am I doing? Okay, yeah. So we had 104 in the positive form, which is this. Ignore this stuff, okay? When you invert the digits, you get this like, wait a minute. Okay, my bad. The question is saying the values. Basically, it is saying that we need to find the inverted binary value for 104. You see, so we first found the value for 104, positive 104, and then we inverted that. So you see here, this is the binary value for 104, positive 104. Again, positive. To convert it into negative form, we first inverted it. By inverted, I mean flipping the values. You get 1 0 0 1 0 0 0 1 1 1 1, and then we add 1 into it, which gives us this final equation, which is equal to a negative 104. So this was exactly what we studied right now. Now, previously, if you guys remember, we were discussing subtraction, right? Subtraction. And I told you all one thing. Let's say we have 15. 15 plus minus 7. What's the answer to this equation? It is 15 minus 7 which again is going to be 8. We are going to be using the same concept in binaries. Let's say we have 20, let's say we consider the binary value of 20 minus the binary value of 10. Now, if we go directly like this, we have some rules which are like if you subtract 0 and 0, you need to write 1 and stuff like that, which is really, really confusing. And I, for my own AS exam, didn't even memorize them. And now, what's the easier way? 20 minus 10 could also be written as 20 plus minus 10. What did I do? We are doing the same addition. Guys, just see, we are just doing the same addition, but I converted the positive 10 into negative 10, right? So what's the purpose behind this? I am just meant to say that let's say 1010. Just let's talk in 4 digits, just to simplify it. 1010 is the positive form of 20, let's say. And then we have 1101, which represents the positive form of positive 10. Now, if we want to subtract the two, we could convert this into this form where we are going to be adding the two binary values in the same way. We are going to be using the same rules, but the only difference is that we are going to be converting the positive 10 into negative 10. We have 1101. How do we convert it into negative form? You flip it first, right? You get 0010, and then we add a 1 into it, into this part. 0 plus 1 is 1, and then we have 100. This is your negative 10 binary value. This was just an example because these aren't actual binary values for 10, but let's say if they were, we had to do it this way, right? We get 0011, and now we want to subtract the two values. Just add the two values, because you see we solve this part of the parenthesis. We have this positive 20, negative 10 is basically this, and now what's left? We have a simple positive sign in between, which we need to look for now. And so let's add the two forms. We have 1010, and then we have 0011. And now we need to add. 1 plus 0 is 1. 1 plus 1 is 0 with 1. 1 plus 0 is 1, and 1 plus 0 is 1. This new answer 1101 is basically again 10. And these two values are not same because we didn't consider taking them as actual values. Perhaps this was 1248, 1248, 12, 12 and 13. Okay, this binary value was basically 13, and then this was 1248, 1248. This was 10. So we tried to subtract 10 from 13, which gave us an answer of -3. And so this value basically represents -3, not +3, -3. And so if we again do it in the long way, we are again going to be getting the same answer. So I hope this is clarified. This isn't that much of a complex concept, but yeah, wait, let's bring a proper example from the book. Wait a minute. Wait a minute. Yeah, binary subtraction. Let's add 95 and 168. Let's just subtract, copy this entire thing, and then it would be easier to understand. We have this up here like this. Yes. Let's enlarge this. My bad. Let's enlarge this. Okay. So if we wanted to subtract 95 minus 68, this would be similar to adding 95 and minus 68. So 95 minus 68 is similar to adding 95 and -68. This is the main logic thingy which I was talking to you all previously. Now we have 95 and then we have -68. Now this part represents, okay, this part represents 95, positive 95. And just to make it a bit simplified, you see they again used it -128 up here just to reduce the space, because you see representing any value in 2's complement form could also be like a 2's complement form value could also be considered positive. Like we see we have +95 up here, but this lower part, this is basically -68. And how did we reach this -68? Again, they would have had positive 68 and then flip it up. Let's do it, guys. Why are we talking? Let's do it. 1 2 4 8. Perhaps let's do it up here. We have 68, right? We're gonna get 64 0 0 0 0 1 0 0. When we flip this, what do we get? We're gonna get 1 1 0 and then 1 1 0 1 1 1 0 1. This, and then when we add 1 into it, 1 plus 1 would be 0, again 1 up here, 1 plus 1 would be a 0, 1 plus 1 up here, 1 plus 0 is going to be 1 1 1 1 0 1. Is this similar to this? Let's compare it. We have 1 0, my bad, we have 1 0 1 1 1 1 0 0. Yes, 1 0 1 1 1 1 0 0. This is 100% same, right? And so when we add the two values, what is 1 plus 0? We have 1. 1 plus 0 again 1. 1 plus 1 is a 0 with a carry. We have a carry up here. And then 1 plus 1 plus 1 is 1 again with a carry. And then again 1 plus 1 plus 1 is 1 again with a carry, and 1 plus 1 is basically 0 again. 1 plus 1 is 0 with a carry into the next element, and then 1 plus 1 is again going to be 0 with a carry up here, and then 1 plus 1 is again going to be 0 and a carry up here, and you see we get the ninth element up here. And again, this is an overflow error. Overflow error. Sometimes in the exam they give you this question where you get this 9 bit, and then in the last part they are asking like there has been an error. Like there are some possible ways. One possible scenario is where they ask that what was the possible error, what was the error basically, and then you need to mention overflow. And sometimes this overflow thing is of 2 marks, where you need to talk about, first mark is about overflow, and then the second mark is where you need to talk about, yes, the bit exceeded into the ninth bit, or which was larger than the register's capacity. Now, how could larger than register capacity? Now, how do they test you on this? Basically, they could give you a scenario where they say that we have a register which has 8 bits, only 8 bits. And so if you have 8 bits and you get a 9 bit answer, they later on ask you in the last part that what's one possible error in here, and then you need to talk about that, yes, there is this overflow error because, and why did this occur? Because your register was of 8 bits and sorry, the value exceeded into the ninth bit. So yeah, this was something which I wanted to talk about today. This was quite important because in today's class, we studied about denary form. Firstly, denary, which was the number system, denary number system. Then we studied about first ones complement and twos complement, which was basically the concept of converting positive into negative numbers. Then we studied addition. Again, those rules, those are really, really important. You guys need to memorize those rules. And then finally, subtraction, which was totally a new concept of AS. That was all for today. I hope you all enjoyed the class. And if you guys haven't subscribed to my channel, please do that too. And I would be sharing the recording up there too very soon, inshallah. And so if anyone haven't watched it or wants to go through the video again, they could just watch it from there.